Hello student, let's begin analog to digital conversion. So this digital signals is superior to an analog signal because it is more robust to noise and easily recovered, corrected and amplified. Means this is a very easy to find out the errors. For this reason, the tendency today is to change an analog signal to digital data. In this section, we are going to discuss two techniques here, plus code modulation and the delta modulation. So here the digital signal means what here? The digital signal is the signal that represents the data as a sequence of discrete value. At any given time, it can only take on one of the finite number of values, where the analog signal is any continuous signal for which the time varying feature of the signal is representation of some other time varying quality, that is analogous to another time varying signal. So in this analog to digital convergence, which is having two techniques. So first one is plus code modulation and the delta modulation. So what is that first one? The plus code modulation, the most common technique to change an analog signals to digital data is called plus code modulation. I am repeating, the most common technique to change an analog signal to digital data is called plus code modulation. So this plus code modulation has following three process. One is sampling, second one is quantization, and third one is encoding. So here this PCM consisting the three analog signals: sampling, quantization, binary, encoding. So before we sample, we have filtering the signals. First it is going to filter the signal, the limit the maximum frequency of the signal as it affects the sampling rate. So it is going to filtering the signals limit maximum frequencies, then it is signals as affected to the sampling rate. So next one, the filtering should ensure that do not distort the signal, that is remove high frequency component that affects the signal shape. So it is removing the high frequency of the component, so that effects goes to signal shape. So here in this diagram we can see the component of the PCM encoder plus code modulation. So first one is diagram shows the idle sampling. Then after that the natural B diagram shows represent the nature of the sampling, how it is. Then after that the flat top sampling. So these are the components of the PCM encoders. So first of all we are going to see what is the sampling. So here the sampling is the first step in the PCM. So the sampling is the process of measuring the amplitude of the continuous. So it is going to measuring the what amplitude of the continuous. So the time signal at discrete instance. So it is a discrete instance converting the continuous signal into discrete signals. So here there are three sampling methods. Again it is having the three methods, that is idle, nature and flat top. So first one, what is the idle? So idle is also known as the instantaneous sampling plus from the analog signals are sampled. So this idea sampling method cannot be easy implemented. So it is a more difficult to implement this idle sampling. So an impulse at each sampling instance. So sampling here. Next one, the natural sampling. The natural sampling is a practical method of sampling in which plus have finite width equal to t. So here the ts is the referred as the sampling of the interval, and fs equal to 1 divided by ts, which is called as sampling rate or the sampling frequency. So nature of sampling means what here? The nature of sampling is the practical method of sampling in which the plus have finite width equal to t in the result of the sequence of sampling that retain shape of the analog signal. So in the diagram we can see here how the analog signals here and as well as here and here. These are the analog signal in the three different types of sampling. One is the idle sampling, which is using here TS, and the natural sampling, and third one is flat top sampling. So it is from the topper side, and which one it is going to the exact discrete where it is the data is flow. So next one, the third one, which is flat top sampling. So the flat top is sample and the hold likely natural but with signal amplitude value. Means what here? The comparison to the natural sampling, flat top sampling, can be easily obtained. In this sampling technique, the top of the samples remain constant by using a circuit. So this is the most common sampling method used. So the process is referred to plus amplitude modulation, PAM, and the outcome of is the signal with analog non-integer values. So note here, according to the Nyquist theorem, the sampling rate must be the at least 2 times highest frequency contained in the signal. So Nyquist sampling rate for low pass and the band pass signals. So in this diagram we can see here this one is the first one is Nyquist rate of sampling, which is fs minus 2f which is, and the B diagram represent overseas sampling fs equal to 4f, and the C diagram show is the sampling which is fs equal to f, that is the third one. So here are the examples, some more examples are given. So these diagrams are shown to recover of the sampled sine wave for the different sampling rates. So again these are the some examples consideration. So here are the sampling examples. The clockwise, with the only one hand it is rotating in the, so in the first diagram we can say that the sampling at Nyquist rate t equal to t divided by half means the samples can means that the clock is moving either forward or backward, which is 12 to 6, 6 to 12, 12 to 6, 6 to 12. So in the B diagram we can see that the oversampling above Nyquist rates Ts equal to t divided by 1/4, which is sampling shows the clock is moving forward 12 to 3, 3 to 6, 6 to 9, 9 to 12. So next C diagram shows undersampling below the Nyquist rate Ts equal to t into 3 divided by 4. The samples clockwise is moving backward from 12 to 9, 9 to 6, 6 to 3, 3 to 12. So this is the examples of how the sampling clock with only one hand. So these are the examples. So next one we can see quantization. So what is the quantization means here? The result of sampling is the series of plus with amplitude values between the maximum and the minimum amplitude of the signal. So meaning of this, when the results of sampling comes, the series of plus with amplitude, the values between maximum and minimum amplitude of the signals. The set of amplitude can be infinite with non-integral values between two limits. So this quantization, the set of amplitudes can be infinite with the non-integral values between two limits. So in the two limits, we are going to read the values in the max and minimum. The sampling results in the series of the plus of the varying amplitude values range between the two limits minimum and a maximum. So the amplitude values are the infinite between the two limits. So we need to map the finite amplitude values onto the finite set known values. This is achieved by dividing the distance between minimum and maximum into L zones, each of highest, which is equal to the max minus minimum divided by L. So this is the how quantization. So the quantization levels are: the midpoint of each zone is assigned a value from 0 to L minus 1, the resulting in the L values. So each sample falling in a zone is then approximate to the value of the midpoint. So here are the some points to quantization zones. Assume that we have the voltage signals with amplitude V minimum equal to minus 20 V and the max equal to 20 plus V. So we want to use L equal to 8 quantization levels. The zone width, which is equal to 20 minus 20 and divided by 8, which is equal to 5. So the 8 zones are minus 22, minus 15, minus 15 to minus 10, minus 10 to minus 5, minus 5 to 0, 0 to plus 5, plus 5 to plus 10, so and up to plus 20. So the midpoint are the, so it is find out in the midpoint, so that half between the two values. So assigning code zone, so this quantization, after calculating the values which process select from the middle of each zone, so which is the values are minus 17, minus 12.5, minus 7.5, minus 2.5, 2.0, so and so. So next one, assigning the code to zone. The each zone is then assigned a binary code. The number of bits required to encode the zone, or the number of bits per sample, as it is commonly referred to the obtained follow. So NB, which is equal to log 2L. So given our example, NB equal to 3. So the 8 zone or level code, therefore 0001. So these are the binary numbers. Assigning code to zone. So this is the quantizations of the coding and the sampling designing. So quantization error are when the signal is quantized, we introduced an error. The code signal is an approximate of the actual amplitude value. The difference between actual code and coded value at the midpoint is referred as the quantization error. The more zone are the smaller, which result in the smaller error, but more zone, the more bit required to encode the sample higher bitrate. So quantization error and SNR. So signals with the low amplitude values suffer more from quantization error as error range is fixed all the signal level. So again in this they are using two approaches. One is quantization level, follow the logarithmic curve, smaller at the lower amplitude and the larger at the higher amplitude. So compounding the sample value are compressed at the sender into logarithmic zone and then expand at the receiver. The zone are fixed in the highest. So bit rate bandwidth requirement PCM. So here the bit rate, the PCM signals can be calculated form of bit rate equal to NB into Fs. So bandwidth required to transmit these signals depend on the type of line encoding used. Refer to previous section for discussion and the formulas. A digitalized signals always need more bandwidth than the original analog signals. Price we pay for robustness and other feature of the digital transmissions. So this is the examples. PCM decoder. So to recover analog signals from digitalized signal, we follow the following steps. We use a hold circuit that holds amplitude value of a plus till the next plus arrives. We pass these signals through a low pass filter with cutoff frequencies that is equal to highest frequency in the per sampled signal. The higher value of the L, less distort signal is recovered. So these are the components of the PCM decoder. So digital data will going to send in the PCM decoder. So which is make the connect samples low pass filter. Again it is amplitude analog signal to the time. So this is the example. Next one, the delta modulation. This scheme send only the difference between plus if the plus at the time which is t plus n is the higher in amplitude value than the plus at the time t n. Then the single bit says 1 is used to indicate the positive value. If the plus is lower in the value, the resulting in that the value which is considered 0 is used. So this scheme works well for the small changes in signals value between samples. If the changes in amplitude are large with large this well the results in large errors. So this is the diagram represent the process of delta modulation. So generated binary data which is representing in zeros and 1. So this is the delta modulation components, analog signals that is sent in the delta modulation modulator. So with again inside it is connected to the comparator. So that is connected to the so this is the delta modulation components diagram. So next one, the delta PCM, which is D delta PCM. Instead of using one bit to indicate positive and the negative difference, we can use more bit quantization of the difference. So each bit code is used to represent the value of difference, and more bits are more levels, the higher the accuracy. So next one, the encoding means what here? The encoding is digitalizations analog signals done in the encoder. So after each sampling is quantized and the number of bits per sample is decided, each sample can be changed and a n bit code. So encoding minimize the bandwidth used. So next one, the transmission mode. So the transmission of the binary data across a link can be accomplished in either parallel or the serial mode. In the parallel mode, the multiple bits are sent with each clock tick. In the serial mode, one bit is sent with each clock tick, while there is only one way to send parallel data. There are three subclasses of the serial transmission: asynchronous, synchronous, and isochronous. So in this topic we are going to discussion what is the parallel transmission and what is the serial transmission. So here the sender is going to send the 8 bit are sent together. So we needed 8 lines to at the receiver side. So here, so this is the what data transmissions and the modes. So here in this parallel transmission, the required n communication lines, the wires in the example just to transmit the data stream, because this is the expensive parallel transmission is usually limited to the short distance. So here the parallel transmissions 8 bit are sent together, so we needed of the 8 lines parallel transmission, usually because of the limited to the short distance. So next one, the serial transmission. So in the serial transmission, one bit follow another. So we needed only one communication channel rather than n to transmit data between two communicating devices. So that we can see in this figure. The sender is going to sending the data and to the receiver side. So here is the gap between data units. See in the diagram, the stop bit is 1, then the start bit is 0. So this is the direction of the flow, this data. So the advantages of the serial over the parallel transmission is that the only one communication channel. Serial transmission reduce the cost of the transmission over the parallel by roughly a factor of n. So here the since communication within device in parallelly convergent device are required at the interface between the sender and the line parallelly to serial and between the line and the receiver. So here the serial transmission occurs in one of the three ways, that is asynchronous, synchronous and the isochronous. So what is the asynchronous transmission means what here? So the asynchronous transmission is named because the timing of the signals is unimportant. Instead of information is received at the receive and translate by agreed upon the pattern. So as long as those patterns are followed, the receiving device and can retrieve the information without regard to the rhythm in which it is sent. The patterns are based on grouping the bit stream into bytes. So each group, usually 8 bits, means that it sends along the link as unit. The sending system handles each group independently. So this is followed in the asynchronous. So this diagram is representing asynchronous. So gap between the data units we can see in these diagrams. So here in the synchronous, transmission, a bit stream combined into longer frames, so which may contain multiple bytes. The frame is identified with the start and end of the byte. So here the each byte, however, introduced onto transmission link without a gap between the next one. So it is next one, the asynchronous, isochronous means, so isochronous transmission, we cannot have uneven gaps between the frame. So here it is not providing the gaps. So transmission of the bits is fixed with equal gaps. So it is providing the equal gaps in the isochronous. So these diagrams we can view in the this networking books that available. that is isochronous diagram. So this is the end of the analog to digital conversion. Okay, so in this model, the transmission mode, which is two types, the parallel transmission and one more is the serial transmission. So in the serial transmission, again it is considered as the three types of asynchronous, synchronous and the isochronous. So this is the completes your second unit. So remaining portion we can see in the next class, next video. Thank you.